discuss about helium neon laser. This was actually fabricated by the scientist Ali Javan and his co-workers in the Bell Telephone Laboratories in USA in the year 1961, and helium neon laser was the first gas laser to be fabricated. Here the lasing medium is a mixture of helium and neon gas, and electrical discharge is used for optical pumping. So let's see the construction part now. As you can see, it consists of a long, narrow discharge tube. This tube is of approximate length 80 centimeter, 80 centimeter, and diameter 1 centimeter, in which we have a mixture of helium and neon in the ratio 10:1. So this forms the lasing medium, and this will be enclosed in between two mirrors, which will be the resonant cavity. One of the mirror is perfectly or completely reflecting, and the other one is partially reflecting so as to take the laser beam out. And here discharge tube is filled with electrode, and they are connected to high voltage, that is 10 kV voltage power supply is given to this. Now going to the working part of it. So we have here, when the power is switched on, discharge actually occurs inside the tube, and electrons and ions will be produced in the process of discharge. They will be accelerated towards their respective electrodes. So the energetic electrons collide with helium atoms and excite them to level, say, F3 here. So in the left side we have the energy level for helium, and in the right side we have drawn the energy level for neon. So the energetic electron, when they collide with the helium atom, the helium atoms will be excited to the higher level F3, and which is actually a metastable state having an energy 20.61 electron volt. So this happens to be a metastable state. So hence the atoms, excited atoms, stay here for a longer time, because it's not the excited level, it is a metastable state. Its lifetime here will be more, so atoms tend to stay here for a longer time. So it cannot come down through spontaneous emission because it is a stable state. So but it will try to come back to the ground level. So by some other method it has to give out its energy. So what it does here is they collide with the neon atom by transferring its excess energy to neon atom through a collision. So here energy transfer by collision occurs, and the excited helium atom give its energy to the neon atom on collision. So as a result, neon, which is in the ground state, will be excited to the higher levels, say E4, and some of them will go to E6 level. So here you can see E6 level, that's the highest level of neon, is comparable in energy to the F3 level of helium. So both E6 of neon and F3 level of helium is comparable in its energy. So discharge to the gas mixture will continuously populate the excited energy level of neon, that is E6. And here E6 and E4 are again metastable state. So we get a population inversion between the level E6 and E5 as well as E6 and E3. So various transitions can take place, and I have drawn two transitions here, that is from E6 to E5, which results in a laser light of 3.39 micrometer, and from E6 to E3, which result in 6329 angstrom and falls in the red light. So this is the lasing part or laser that we the output that we get here is a red color, that is having a wavelength 6329 29 angstrom. So this is how lasing action occurs in a typical helium neon laser, and a power output obtained is approximately about 50 milliwatt, and this is compared to solid state laser. This is more monochromatic and more directional, and they continuously give a laser output without any need for any cooling arrangements. But there is one disadvantage for this gas laser, because they can be eroded by the gas discharge. Mirrors can be eroded through continuous gas discharge, and they may have to be replaced. So we have seen a 4-level pumping scheme in helium neon laser, where 10 kilovolt of energy or power is applied to ionize the gas. Energetic electron excite the atom through collision, and you see that the excited level of helium at F3 is comparable to the E6 level of neon. So it can transfer its excess energy to neon through collision. So that transfer is termed as resonant energy transfer. So neon has the excited level at 20.66 electron volt, and that is comparable to the helium F3 level. So, and then we have seen the working of the laser, and the output is the red light 6329 angstrom. So this is about helium neon laser construction and working